Hello everyone, my name is Abhinav Mohanty and this presentation will provide a brief overview of the OWASP IoTGoat project and will also discuss the future roadmap. In this presentation, I will also demonstrate on how you can quickly set up and start using IoTGoat. However, before I begin, I would like to formally introduce myself. I'm a PhD candidate at the University of North Carolina, Charlotte, and my research focuses on IoT firmware security and hybrid mobile app security. I completed my master's at UNC Charlotte with a concentration in cybersecurity. And I also have 2 years of experience working in the industry as a security engineer. And I'm one of the contributors of the IoT Goat project. The OWASP IoT project was started in 2014 by Daniel Meisler and Craig Smith with the goal to help manufacturers, developers, and consumers better understand the security issues associated with the Internet of Things and to enable users in any context to make better security decisions when building, deploying, assessing, or buying IoT technology. The OWASP IoT project has a number of sub-projects as well, and they have been cited in numerous publications and information security standards globally. The OWASP IoT project has collaborations with organizations from both private and public sectors, and more information about this can be found at the OWASP IoT project page. As I mentioned, there are numerous sub-projects under the OWASP IoT project. Some of the most prominent ones include the OWASP IoT Top 10, which discusses the most prevalent 10 top IoT vulnerabilities. The initial list of the top 10 was released in 2014, and it has gone through several changes, and the latest update was released in 2018. Another important project is the OWASP IoT Top 10 2018 project. The, the intention of this project is to map the OWASP IoT Top 10 vulnerabilities to industry publications and sister projects. This will help in providing resources that enable practical usage of the OWASP IoT Top 10. ByteSweep is another product outcome of another project and is a really good and handy free to use firmware analysis tool. Recently, the firmware security testing methodology was also released in the form of a Git book by Aaron Guzman, who's also the lead of the IoT Goat project. This methodology divides the testing of IoT firmware into 9 stages and formalizes it. So, a relatively new project which was kicked off in March 2019 is IoTGoat, and this is led by, as I mentioned, Aaron Guzman. IoTGoat is a deliberately insecure firmware based on OpenWRT, which is a widely used and highly customizable router firmware. IoTGoat is maintained by OWASP to educate users on how to test for the most common vulnerabilities found in IoT devices. The vulnerabilities included in IoTGoat are based on the OWASP IoT Top 10 to keep it as real as possible, and also includes some Easter eggs that have been contributed by the project contributors. IoTGoat is an open source learning tool I, targeted towards IoT software developers, hobbyists, researchers, and IT professionals. The first version was of IoTGoat purely focuses on firmware vulnerability challenges, but we are working on a subsequent release which will include open hardware vulnerabilities as well. The date of release has not been finalized yet. So as I mentioned previously, IoTGoat is based on OpenWRT, and this makes it compatible with over 1400 circuit boards. It can be easily built for multiple platforms that include MIPS, ARM, Arch, and it can even be built for x86 systems. The build configurations have already been developed and are readily available on the GitHub repository of the project. The IoTGoat repository already has numerous forks and is being used in CTF competitions to test the competency of new hires and to educate them. It is also used in popular security conferences like IoT Village. IoTGoat can also be used to validate the efficiency of vulnerability scanners, and it can also serve as a test bed for security standards such as the OWASP IoT Security Verification Standard, also known as ISVS, and evaluation of security frameworks such as the SESIP. Another interesting and I think quite important use of IoTGoat is to teach IoT firmware penetration testing skills in a classroom environment. As part of a cybersecurity course delivered at UNC Charlotte, we designed a project where we replaced the 6 weeks project. Uh, sorry. As part of a cybersecurity course delivered at UNC Charlotte, instead of a traditional 6 weeks project, we designed a project where we installed OpenWRT on actual routers and provided those to students. We used the original OpenWRT since IoTGoat was still in development phase at that time. The new project was designed to provide hands-on IoT penetration testing skills to the students and was divided into 3 phases. The first phase was network security, in which the students were required to configure IP tables on OpenWRT. IP tables is the standard Linux firewall. In the second phase, the students were divided into groups and were required to do penetration testing of the OpenWRT web UI. The third phase of the project was software security, and in this phase, the students were required to exploit a DNS mask buffer overflow vulnerability and obtain a root shell. In designing the project, we discovered multiple 0 days cross-site scripting and cross-site request forgery vulnerabilities in OpenWRT and included those in IoTGoat as well. The vulnerabilities were reported to the OpenWRT security team and got fixed. This case study provides good evidence that IoTGoat can be highly efficient in teaching penetration testing skills in a classroom environment. Now I will briefly discuss some of the vulnerability challenges that are included in IoTGoat, and in the later half of the presentation, my co-speaker Parag Mhatre will demonstrate some of these challenges. IoTGoat has weak and hard-coded user credentials compiled into the code base and can be found by reverse engineering and analyzing the firmware file system. It also has insecure network services that include a vulnerable UPnP connection and a vulnerable and downgraded DNS masks that contains heap and stack overflow vulnerabilities. IoTGoat also contains a secret developer diagnostics page that can be used to obtain useful information about the router that can be used in exploits. It contains a persistent backdoor daemon that is configured to run each time the router restarts. It also contains multiple cross-site scripting vulnerabilities that can be exploited to hijack the entire browser. The package update configuration on IoTGoat has also been made insecure and can lead to man-in-the-middle attacks, which can further lead to injection of arbitrary package payloads. Going further, we have downgraded number of software components and included the ones which contain known CVEs. Some components that are vulnerable include, as I said, DNS mask, PPPD, the Linux kernel, BusyBox, and many more. Privacy protections have also been removed, and personal information is captured and stored insecurely. This is complemented by improper encryption settings, which leads to further insecure storage. Device management capabilities such as system logging, monitoring, and auditing capabilities have also been disabled. Browser headers that prevent framing have been removed in certain places, and these can be combined with missing CSRF protections to launch disastrous cyber attacks. One example is that a hacker could i- one ex- one example of this is that a hacker could inject arbitrary firewall rules and can take over your entire router as well. For future versions of IoTGoat, we also plan to include hardware challenges and open boot vulnerabilities as well. There are several methods that you can use to get started with hacking IoTGoat, depending on your testing approach. For those who are looking to extract the file system and analyze the configurations and the binaries statically, they can download the latest pre-compiled firmware release from the release page on the GitHub repository. For the dynamic web testing and binary runtime analysis, the quickest and easiest way to get started is to download the virtual machine disk image, which is also provided on the GitHub repository, and create a custom virtual machine. And I will demonstrate that in a minute, how to do that. You can also emulate you can also emulate firmware with open source tools such as Firmidine, RMX framework, and firmware analysis tools, which leverage QEMU to virtualize IoT Goat locally. We also provide a compiled firmware image to flash IoT Goat on Raspberry Pi 2 as well. Now I will show you how you can download the VMDK file and set up your custom IoT Goat machine and start using it. So this is the getting started page and the link is provided in the presentation. And this is a GitHub page of the OWASP IoT Goat repository. It contains instructions on each method of getting started, and we will focus today on how to set up as a virtual machine. So by clicking this link, I can download the IoT Goat x86 virtual machine image. And since I've already downloaded it on my machine, I will just use that. This link also contains the Raspberry Pi build as well and the source code of the IoT Goat as well. So I'll go to so I'm using VMware Workstation, and you're free to use VirtualBox or any other machine you want. So I'll create a new virtual machine and I'll select custom advanced. My hardware compatibility is correct. This is workstation 15 and I'll click next. So since I'm using a pre-compiled VMDK image, I will choose the option to install operating system later, since that virtual machine disk already contains the operating system. I'll click next. The operating system is Linux. Here, make sure you select a 32-bit, not a 64-bit, and you can select either 4.x or 3.x. I'll go with the 4.x. So here I'll select where I want my virtual machine files to be stored. And I'll go to my desktop and just select images. Click OK. Next. So this is fine. One processor and one core per processor is fine to start OpenWRT. So 256 MB is fine. And you don't need to, you don't need more RAM than that. That's usually the standard RAM in embedded devices. And make sure you select network address translation and not host only networking. LSI logic is fine. Don't change that. SCSI recommended. That's also fine. Do not change that. So now is the main thing. So this is the place where you'll link the VMDK that you already downloaded, or the VDI if you're using VirtualBox. So I'll click on use an existing virtual disk and click next. Now I'll give it the path of my virtual disk and click next again. So you can choose to convert or keep existing formats. This won't matter. It's just a format of the virtual disk. So I'll just choose to keep existing format to be safe. And then I'll just click finish. So I'll give it like 5 seconds. And once everything is set up, I'll power on this virtual machine. So it says cannot connect to the IDE. That's because we're using the VMDK already downloaded. And do you want to try to connect this virtual device every time? No. So now it will start booting up and I can select OpenWRT. So give it like 30 to 45 seconds and it should boot up. So you can see it's loading bunch of drivers. Okay, I think it's booted up. So now, so basically now your virtual machine is running OpenWRT. I'll show you how you can access the web console as well. So if you write if config and press enter, you'll see all your interfaces. Okay, I can't scroll up here. I'll write less. Yeah, now I can see. So we are interested in the BR LAN, which is the bridged LAN interface. And note down the IP address, the INET address of this interface. And this, you will use this IP address to access the web console of OpenWRT from your host machine. So the IP address is 192.168.206 and 135. Let's try to access this from my browser. 192.168.206 and 135. Okay, so my antivirus seems to block it because it's HTTP, not HTTPS. Okay, so now you can access your web console and from here you'll enter the password and go forward. Thank you everyone. And now I'll hand over the presentation to my co-speaker Parag Mhatre, who will tell you how to log in into the web interface and show you challenges as well.
Thank you, Abhinav. Uh, I'm the second presenter for this session. My name is Parag, and I just joined Bank OZK as application security engineer after I graduated with masters from University of North Carolina at Charlotte. I am a networks guy who developed interest in security, offensive security to be precise, and I'm a contributor for the OWASP IoTGoat. Um, so let's get on to it. Abhinav has already started, given us a walkthrough about how to get started with IoTGoat and how to install it. So I'm just gonna boot up my version of IoTGoat here, and I already have a Kali instance running. So let's just get it started. Okay. Mhm. Okay, so let's just check the IP address of the instance. Okay, so we have 192.168.242.132. I'm just gonna make sure that we do have access to the UI and are able to connect to it. Mm, yep, okay, just accepting the risk. And we are there. So the first thing that I'm gonna do is what everybody does. I'm gonna run a network scan on the IP address of IoTGoat on the web server of IoTGoat, just to understand which ports are open and if any services are listening to them, and make nmap try and identify those services. So nmap, um, let's do this and all ports 192, 168, 242, 132. Okay. And as we can see, it has already discovered some ports there, port 53, 80, 443, 22. Nothing surprising there. We'll wait for the interesting stuff. So one other thing that we can do till then is try and extract the IoT firmware. So this is the image of the firmware that runs on IoTGoat. So I'm just going to use Benwalk I'm going to use Benwalk to extract the firmware. So let's do Benwalk extract IoTGoat. Okay. And while this runs, we can see that it has started extracting firmware, squash face, IoT root. Okay. Let's try to see the interesting file, etc shadow. Okay, that's here. Okay, so as we can see, this has two users, root, IoTGoat, which have hard-coded passwords in there. So one thing that we can do is try and crack these passwords using Hashcat or John using a word list. And I would suggest that you use a very popular word list from a botnet in 2016, the Mirai word list, and you should be good. Getting back to the Nmap scan. Okay, so uh, since we are trying to run a scan on all 65,535 ports over here, it will take a lot of time. So I went ahead and got a screenshot of a scan that I ran last night. So here is the scan result. We can see that there are multiple ports that are open over here. There is the 65534 that's open, and there is this 7429. No, that's filtered. So there's 5515 that's open, and we don't know the service that's running on there. There is this 5000 port with UPnP running, and this is an interesting port, should be enumerated definitely. Uh, Everything else seems to be filtered or is not very interesting. So let's try and connect to this port and see what happens. So what I'm gonna do is I'm gonna just stop this nmap scan and resize this. Okay. So I'm gonna try and connect to 65534 using netcat. So just to NC numeric only verbose and 192, 168, 242, 132 at port 65534. Let's see what happens. Okay, so as we can see, and Netcat did connect, and we can see a remote login screen over here. At this point of time, if we had actually cracked the password after reverse engineering the firmware mm, over here, okay, from there, then we could have tried and connected using we could have tried and connected using those credentials. For now, I'm just gonna try default credentials. So just try root, tour, and it doesn't get me through. So I'll try to connect to the other port that we have found, and that's interesting. So same command, same IP, and a different port. So the port is 5515. So as we can see, we connected to it says successfully connected to IoTGoat's backdoor. So I'm guessing this is a remote shell. Let's see. And yes, this is a remote shell. Okay, so we could do the same thing that we did using reverse engineering. We could cat out the shadow file. Yep, or we could cat out the password file as well. Yep. So we could use a combination of this to again crack the passwords and get direct once we crack those passwords, we could use them here, or we could SSH them. As we can see that SSH port is open as well. So I'm just going to log into the IoTGoats interface using the password that I know. And so once you do get access to the UI, you can just surf around and look for stuff. As I said, UPnP is interesting. One thing that I suddenly noticed is that secure mode is not enabled. That is something to make note of. No, I'm gonna show you a cross-site scripting vulnerability that we developed in IoTGoat. So if we go to the wireless page and if we go into the wireless settings, Wi-Fi settings, and we go to the SSID, I'm just gonna go ahead and try and run. Oh, it's already there. So I'm just gonna go ahead and run this payload over here. It says image source and the source is malformed. So it should call the on error event handler and run this JavaScript. So let's just see and try and apply this. So waiting for it to apply and yep. So as we can see, this field was vulnerable to a cross-site scripting vulnerability. Another thing that I'm gonna try and do is show you a CSRF vulnerability. So I'm gonna start burp suite for this, the community edition that comes with Kali, and I'm gonna do. I already have burp suite configured, so I'm gonna use Foxy proxy to start my proxy, and so should be, yep. So I'm gonna just start a temporary project, and yep, I'm gonna go to proxy, turn the intercept off, and just go to the firewalls page here. So there is a, this is just the burp suite SSL certificate warning. Um, so I'm going to go to the port forward page and try and insert a rule, say rule 2, and give it a protocol, external port as 3434, LAN, internal IP address as 132, 192, 168, 242, 132, and the internal port as 34, and just do add. Let's try and apply this. I forgot to turn the intercept on, but we can go to the HTTP history and see the post request that was there. Mm, Here. And I'm going to do this once again so we could see it over here. I'm just going to turn the intercept on and test, no, rule 2, 3. Okay, let's do UDP this time. And external port should be 4444. Let's try a different IP address and internal port as 44 and do add. And we can see that this is the post request that was captured by burp. Um, we can see that it is being sent to CGI bean Lucy admin network firewall forwards. And there is a system authentication cookie. And then there is this token that's being sent. So let's go to the parameters to look at this in a better way. As we can see, this are the parameters, and this is a system authentication cookie, which I believe is the login cookie. And there is this token, which is supposed to work as a CSRF token, but for some errors on the backend, it doesn't get validated. So I'm just going to let this go, and actually, I'm going to keep it here and pull up a page that I created. So this firewall rule HTML page, I'm just going to open that with mouse pad and show you that I have included all the necessary fields from the form. So it is posting to admin network firewall forwards, just like here. And it has all these necessary fields like it has a name called SSH, protocol is TCP, there is external port, internal IP address, internal port, internal zone and external zone. So this is all we would need if we had to create a CSRF form and maliciously trick the user to run that. So what I'm going to do is I'm going to put this address over here, and the name of the form is firewall hyphen underscore rule HTML. Okay, here go. So one thing to notice here is that the form was from a different domain, a different website, and this domain is 192.168.242.132. That's the IoT Goats domain. So even if we execute form from a different domain and it gets passed to the server backend, the token didn't wouldn't actually get validated. So as we can see here, the rule was added, and we exploited a cross-site scripting vulnerability. Now, if we were able to execute the cross-site scripting vulnerability to suppose include a payload here and perform some malicious action using JavaScript, say navigate the user out of this from this domain to a different website altogether. Well, that is something that could be done, and I guess you should check that out. Apart from that, one other thing that I wanted to show you was there is a secret page that's included in this firmware. You cannot normally navigate to the page, but if you just type the correct URL, or if you burst the correct URL, then you will be able to access that page, and that would be at IoTGoat CMD inject. So this is a page which gives a root terminal to any user. So this is another thing that is interesting. There are two ways to find this. There are tools available like Dirbuster or GoBuster, which try and find different URLs are which do exist but cannot be found using normal methods. And there is one another method using reverse engineering. So if we just go here and from this file system, if we go to the correct path, okay, so if we go to the correct path, we would be able to find the CMD inject page, and that's another way of finding that. Okay, so this is all I had as far as walkthroughs of the challenges were concerned. Let's get back to the slides. So there are these resources that we do suggest using if you are trying your if you are trying this out for the first time. So there is this firmware security testing methodology that was recently released by OWASP, and it gives you a detailed overview about how to go about while testing a firmware. And the web security testing guide is very famous and utilized by a lot of web application testers. So that's something that we would recommend as well. Apart from that, as far as the future roadmap of IoT Goat is concerned, so we are planning new things to include in version 2, and some things that we did want to include in version 1 but were not able to. So one big thing that we are doing is have high quality solution walkthroughs. So if you go to the GitHub page, OWASP's IoT Goat's GitHub page, there in the wiki section we have started putting down walkthroughs of different challenges, and we want to have a really good documentation of the walkthroughs to set us apart from other projects that are there in the similar field. So that is something that we are trying to do. Apart from that, we also plan to add exploit mitigations in the next version of IoT Goat. So if we have a vulnerability, then we also want the users to go ahead and fix those vulnerabilities in the source code and recompile the firmware to check if the vulnerability did indeed get fixed or not. Apart from that, we also want to include hardware challenges. So we are currently looking at different options to include hardware with the IoT Goat as well. Uh, that is something that's going on as well, and we would like something like extracting firmware using JTAG and other things. So another thing about wireless is that we do want wireless challenges as well, and there is this firmware over the air update challenge that we had something that was working but was paused due to incompatibilities with OpenWRT. So we do plan to make that work and release that with the next version of IoT Goat as well. As far as similar projects are concerned, there are some projects which existed before before we released IoT Goat, and most of these projects were focused on memory corruption vulnerabilities or hardware-based challenges, and we want to so. And IoTGoat focuses more on the software and hardware challenges together. So we want to provide a complete package as far as IoT vulnerabilities or IoT security learning is concerned. Apart from that, I want to give a huge shout out to everyone who was involved with and contributed their time and efforts towards IoT Goat. Project leaders, especially Aaron Guzman, who was very active during the whole phase of the project work and was uh, always took the initiative to help out and guide us contributors as well. So apart from this, I want to thank everyone for giving me this opportunity. Thank you, OWASP. And if anyone is interested to contribute towards IoT Good, I would recommend that you contact Aaron at the given email address here. And thank you.